Hello class, this is Mr. McAllen, and I'm going to go through the review for the test tomorrow. This is the review that we did in class today, and if you didn't know how to do certain problems, hopefully this will help clear that up. So I'm going to start working through some of them. Some of them I'll be commenting, other ones I'll just work right through. On the first one, you have to remember to cube everything in the first set of parentheses and square everything in the second. So you would write out that you have 8n cubed times 121n squared, and then remember that when you multiply the 8 by the 121, that's going to be 968. You're going to have to multiply that up by hand, and that would be n to the fifth. When two numbers with the same base are being multiplied, you want to add their exponents. On the next problem, you first divide 49 by 7, you get 7 in the numerator. You subtract the exponents for x to the sixth over x squared, and you subtract the exponents for y to the sixth over y. On the next problem, when you have an inverse for a relation, it's simply, remember the definition for an inverse is switching x and y pairings. So our inverse set would be written as on our next problem, when you write out the equation of an inverse relation, just switch x and y. On an equation, on a graph, when you have an inverse, you find some xy pairs. So right here we have negative 6, 0. We have, it looks like 0, 2.5. And right here, let's say we have 10, 4. And you plot the new points, so you'd be plotting 4, 10. I'll plot this in red. 2.5, 0. And 0, negative 6. And you should see that you have the inverse plot. Remember that the inverse plot will be symmetric, or will be a mirror image across the line y equals x. So on the next problem, number 6, we want to solve this log equation. So on the right, we're going to compress logarithms. So I'm going to have log of 2x equals log of 4 times x minus 1. So log of 2x is equal to log of 4x minus 4. And now I can just ignore the logs because we have a common log on both sides, and I could solve the equation for what the independent variables of the log functions would be. I should always go back and check that answer too back in the original function. So I'd plug 2 in for x there, and I'd plug 2 in there, and upon plugging it in, I would get log of 4 equals log of 4 plus the log of 1. And we should all know that the log of 1 is equal to 0, so our equation checks out. On our next problem, we have an exponential equation, and remember the secret to solving these is to switch the base to common base. So in order to switch to base 2 and base 2, and then I set the exponent positions equal once I have similar bases. So here I have 2x is equal to 4, x will equal 2, and on this other problem I have 4 to the 1 plus 2x equals 2 to the 6th. I should be 4 to the 3rd. So since I have a common base, now I can set the exponents equal. So I have 1 plus 2x equals 3, 2x equals 2, x has got to equal 1 for this problem. On the next problem down here, if you have a logarithm equal to a number, just switch it back to exponential form. So I would write this as 9 to the 1/2 power equals x, or x will equal 3. Remember, 1/2 power means square root. On the next one I'm going to rewrite that in exponential form. That's a secret special notation there for logarithms. When you don't see a base, you know it's common log. So 10 to the 6th will equal x, or we could say x is equal to 1 million. Moving along, we have a log to simplify. Well, I'm just going to simplify it up here because there's a little more room. Common log of y squared minus 3y plus 2 over y squared minus 1. Now in this problem, to simplify it, you have to factor the numerator and factor the denominator. So I'm going to rewrite that as log of y minus 2, y minus 1. You should know how to factor that by now, that trinomial. And you should also know how to factor the denominator by now, that's difference of squares. And I can cancel those out, and this is the final answer that you have in the book, or at the back of the test. I had to make a little bit of room here because now I'm going to do number 12 in this place that I just did number 11. So if you have problems remembering what we did on number 11, just hit rewind. So number 12, it's a common log of 2 plus x minus common log of x minus 5 equals common log of 2. Compress the logarithms, make one logarithm out of the left. That's going to be 2 plus x over x minus 5 equals common log of 2. Because we have common logs on either side, we can just set the 2 plus x over x minus 5 equal to 2. Whenever you have a ratio is equal to a number, cross multiply, so you have 2 plus x is equal to 2x minus 10. That's just a linear equation now. So you have x is equal to 12. On this next problem, I would just write 6 to the first power. Whenever you have a logarithm is equal to a number, just write it back in exponential form. 6 to the first power is equal to 8x minus 1. You end up getting 8x is equal to 7. So x would equal 7 over 8. The next problem is just asking to express this as a single logarithm. So that's a simplification process. So we're going to just compress the two logarithms. Well, I'm going to first write this as log base b of x to the 5th minus log base b of the root of x squared. And the root of x squared is just going to be x. So this will end up being log base b of x to the 5th over the root of x squared, which is also log base b of x to the 5th over x, which is going to be log base b of x to the 4th, and that would be simplified. Okay, now we're down here at log base number 15, log base b of b to the 5th under square root, so we can write that as log base b of b to the 5/2 power. That half power is a root type. We talked about that in class, so make sure you rewrite the square root as a 1/2 power. And now to answer this question, basically for any logarithm, you say b raised to what power gives you b to the 5/2. And that answer for this one shows that x is, the logarithm has got to equal 5 over 2. On the next one, natural log of e to the 8th, well, this is right over here. Natural log is just log base e of e to the 8th And the answer to that is simply 8. On the last problem, don't forget your asymptotes. This final answer is negative 2 to the x, so it's going to be an upside down exponential, and this would be negative 2 to the x, and that's going to end up getting moved to the left by 3. So I have this asymptote at y equals 0, and my final graph is going to be shifted by 3 units. So I'm going to have the points, well, let me finish graphing it, but this would be the original function flipped over the x-axis, and on the next image you'll see is my final product. And I finished graphing the function, and hopefully you can see that, I'm zoom in a little bit, that I've shown that this function, negative 2 to the x, is moved to the left by 3, and I'm detailing where those points' coordinates are. And since the function moved left from right to left, I didn't have to change the location of the horizontal asymptote. I hope this has helped you. Hopefully you get a chance to practice this tonight, and we'll see you tomorrow. Take care.